What we have here today is a little tube amp that seems to be in trouble. It's a PrimaLuna Prologue One stereo tube amp. Apparently the one channel is shorting out. It's not giving any sound and it's blowing fuses. And from everything that I've read and know about it, it's actually quite a good little amp. It uses two EL34s per channel, and apparently it's about 35 watts per channel. It's got two 12AX7s, two 12AU7s, and the one channel is gone. Now the problem with this kind of equipment where we live on the island of Madeira is that this bloody thing weighs about 16 kilos. That's about 30 pounds or more. And just shipping this off to anywhere that has a proper authorized, licensed repair team is going to cost a fortune. The repair might actually be quite simple, but it will cost a fortune. Now, this thing has had someone look at it, and the diagnosis was that there's an output transformer blown. My instinct is that perhaps that diagnosis might be wrong, and I certainly hope so, because the output transformers on this thing are probably the distinguishing factor on this particular amp, as it is with just about any amp. The quality of the result will depend on the output transformers. So if this thing has actually got a blown output transformer, replacing that is not going to be cheap, and it's not going to be easy to get here. As I said, shipping is a fortune. But also, if you change one, you've got to make sure you get an exact replica of the output transformer. Otherwise, your sound's going to be different from one channel to the next. I'm going to open this up and have a look at it and just pray that the diagnosis was wrong and that we can actually find the fault. Well, the top is off. Quite interesting the way they've done it. They've got these banana type jacks on the bottom here, and they literally, four of them, literally plug in to these 4 points over here. There, and there's another one at the back there. So you literally unplug this and you get your tubes. So we've got the two 12AX7s. I presume that's the input preamp stage. Then you've got the 12AU7s, which is probably the phase inverters. Then you've got a pair for each side of the EL34s. Everything looks pretty neat, just a little bit of dust, but nothing dramatic. And the rest is inside that cabinet. So I'm going to take the tubes out, see if there's anything obvious for a start, and see what we have, and perhaps start looking for some hint as to what we're dealing with here. And here's the first hint of some problem. We obviously had some sort of short here, because this pin there there was a spark over here. It's got a blackened, melted section over here. Not really melted, I suppose, just burnt. And this would be carbon composite that remained on the tube socket. So we've probably got a potential spark gap over there. Now that particular pin, there's the little indent over there, so that's indicating that this is 1. You're looking at it from the top, so it's counterclockwise. So 1, 2, 3. Pin 3 of that EL34 is the anode. So this would have full B+. Now that's not good, because pin 2 is the heater. So 2 and 7, so that one and that one are the heater voltages. So you could have a potential for a spark between the anode, the full B+, and the heater voltage. That is definitely not good. The others seem to be okay. And I was told the one channel is working. The one side is working. So obviously the power transformer, I don't believe this has got two power transformers. The power supply is okay. But that's certainly something to look at when we open it up. And here it is opened up, and I'll tell you what, I like it. This thing is nice. This thing is really neat. All the tubes are point-to-point hand wired. They've got some pretty nice rails on there. Everything is incredibly neat, the way they've done it. You've got your two output transformers here. I noticed that somebody has removed the B plus supply from the center tap of that output transformer. This was, I believe, the gentleman who looked at it before me and concluded that one of the output transformers was blown. I don't know whether he was right yet or not, but anyway, he disconnected that just to get the other channel working without this thing blowing fuses. So output transformer left to right, whichever way you want to look at it. You've got the power transformer over there. The filter caps are hefty beasts over here. Everything is really nicely wired. Everything is neat. There's one pair of EL34s. The other pair, you've got the 12AX7s over there, the 12AU7s over there. Everything point to point over here, very neatly done. You've got a very small board on there for the LED. The switch is point to point over there. This is that there is the input selector switch. This thing's got that's the volume control. The input selector is over here. Also very neatly wired. Everything's protected. Then they have all the, you've got those power resistors over there, directly wired to the pins and to this common rail over there. Oh man, this is a beauty. This is a real beauty. Some of the biasing, this is a choke, 180 milliamp 4 Henry, so this will be on the power supply to reduce the ripple. Everything is in place. Then, I'm not sure what the output voltages here are yet, but you would have the heater supply, which I'm not sure whether it's AC or rectified. Let's have a look. It's those brown wires. Brown wires, AC. Yep. They go straight through. Those two thick brown wires look like the heater supply. You've got a small rectifier here. That's probably a low voltage supply for this board. Now, apparently what this board does, this is the auto bias. It's got a self-biasing system, which is automatically adjusts the bias so that your tubes are always optimally biased, regardless of the heat, of the temperature, and maybe even some tube differences. So they've got a very clever biasing control over here, and that's about the only thing that's really on a PC board. Everything else is hand wired. Now these 1, 2, 3, 4, so this will be 4 separate outputs to the bias voltage, which will be the grid control grid bias. I would presume this is one each. Some filtering, a transistor there. I wonder if that's the voltage regulator or the bias voltage regulator for each one. I'm not sure exactly how the circuit works. I haven't looked at a schematic yet, but this thing is neat. All right. But anyway, what we have seen is that somebody removed the B plus from that transformer, so I presume that's the side that's not working. So the first thing I'm going to do is test see if the output transformers are indeed working, or if one of them is shorted as was reported. Right, so all I'm going to do here is I've connected the speakers. This is the one channel connected to the ground. This is these 3 connectors are ground, 4 ohm, 8 ohm for the one channel, ground, 4 ohm, 8 ohm for the other channel. So depending on which speakers you have, whether you got 4 ohm or 8 ohm, you use the inner ones or the outer ones. I'm connecting ground here, I'm connecting to the 4 ohm here. This is connected just a small speaker, just the one I'm using for testing. And what I'm going to do with the tubes out, no power on, this thing isn't even plugged in. Now that's a very good idea, don't plug this in. We're going to send we're going to feed a signal from the signal generator, just a 1 kilohertz signal. I've got it at 200 millivolts RMS. And I'm going to feed that into the primary of this transformer. Okay, now let's just check which one is which. That one is, well, actually it's this transformer. So I'm going to feed it into the primary of this transformer, and see if we hear a tone over there. So I'm feeding the signal straight into the primary. There's no tube. This thing, that center pin there, the red one, would be from the power supply, and then the white one would go to pin 3, I presume. 1, 2, 3, yeah, that would be the anode. And then the middle one would be to the screen, because this would be ultra linear. So I'm just going to feed it to the center, put the ground of the signal generator on the center tap, and I'm going to touch the one end, and we've got a signal. Okay, I'm going to up the level a bit. So I've got 500 millivolts RMS coming out, 1 kilohertz signal coming out of the signal generator, going into the one side. Remember, this is a center tap transformer because these are push-pull. This is a push-pull stage. So if you want to make sure the transformer is working, you should try the other side as well. So we'll do that. And we've got the signal. So what this is doing, what this is telling us, let's try the ultralinear tappings as well. Yes, and yes. What this is telling us is that when you feed a signal into the primary of this transformer, this output transformer, the signal is getting through to the output. Just one more test is to see whether the 8 ohm one is giving us the same thing. So, yep, it's doing the same thing. This transformer is just fine. So now we'll try the other transformer which was suspected to be blown, and we'll move the speaker to this side. 4 ohm tap. Let's do the same thing, and it's working. Let's try the ultralinear, try this side, try this side. Let's try the 8 ohms. Perfect. These transformers are not blown, at least not under low power, because this is obviously a very low level signal. But we've got continuity. There's certainly no problem with continuity there. This does not mean that these transformers are guaranteed to be fine, because when you put B plus on here, you're playing with a different in a different ballpark altogether. You're putting 400 and something volts, whatever the B plus is on here. And something which may not be shorted at low levels, like the 1 volt that we put on here, may well change characteristics when you apply hundreds of volts on there. But the first test is very encouraging. It looks like the 2 output transformers are fine, which is more or less what I expected, certainly what I hoped for, because an output transformer change on this thing is a serious bit of work and cost. So we've got a problem somewhere else, and my first guess would be that we may have a biasing problem, because when you look at something like this, if you're someone like me who likes vintage electronics, the first thing you suspect is either something just simply shorted or a bad solder connection on here. But in the case of blowing fuses, it'll be a shorted situation, or you suspect this thing. You suspect the modern things on the boards. You suspect that maybe this board is not doing its job properly. So what we need to do is we need to now check. I think the next stage will be to power this up without tubes and make sure we're getting the right B pluses where they're supposed to be. So we can make sure that we're getting voltage coming into the anodes and to the screen grids of these tubes, the 4 tubes. I have a little bit of fear regarding that sparking that we saw on, I believe it's this one. No, it's this one. That anode to heater sparking is a bit strange, but we'll have to look at that. And then we'll just take this one step at a time. It's causing a short, so you can't switch it on, at least not unprotected. Obviously, anything that I put, any power I put on here, any electrical power, will come through the dimmer restriction. But if it is shorting, it's just going to show us a short. So I think we'll start looking at the power supply and try and isolate it to a particular point in the circuit. My guess it'll be one of the tubes. Either there's a short around here somewhere, or the biasing circuit is acting funny and it's actually feeding perhaps positive voltage or 0 volts to the grid of one of those tubes. So it basically biases the tube like a switch fully on, which means you'd have an excess current draw and it would blow the fuse. The tube could also be faulty, but I was told that the tubes that were actually in here when this thing was blown are no longer the ones that are here. And they haven't tested it with the tubes that are here, except for the working channel, of course. So yeah, so that's the next step. I think I'm going to start looking at each one of these stages separately, because ultimately you look at the circuit, forget about that thing there. All that is doing is producing minus 20 something volts to each of these. You could literally take that out, create a little fixed bias circuit of maybe, 3 or 4 or 5 components and do exactly the same thing. What they've done is they've gone fancy. They've created a automatic bias, which is great. Depending on the signal you're getting, on the sound you're getting, on the volume you're getting, this thing adjusts the bias automatically. So that's a great system, provided it works. Because if one of these things, one of these stages, basically forces the tube to short, you've got a problem. So we can actually test all this without the tubes and see if we get something that's obvious jumping out at us. And that'll be the next stage, and I'll report back when I've got something to show you. I think we found something, and it's actually in the transformer that was reported as blown. Now, what I found shows that perhaps the diagnosis was not entirely wrong. And I'll tell you what I did. I'm going to check the resistance. I've connected one end of the multimeter to ground because a short is normally ground. And obviously this thing here connected to the transformer was causing a short. So the only parts that can be shorted to ground would be these pins or anywhere that they go to. Now, what I'm going to do now is I'm going to measure the resistance to ground from each of these connectors. Or actually, I'll start from this one. This is remember the tubes are out. So this thing's coming from the power supply. That definitely is not a short to ground, okay? Because it meets the rectifier diodes and everything else. One of these goes to the one tube's control grid, I think it is, the grid 3. It's the ultralinear connection, and the other one is the anode. And this one goes to the other tube, grid 3, and the anode. So if I measure that point ground, I get 370 ohms, 0.37 meg. If I measure that one, 374, that one, 376. Remember, these resistances are just coil windings, so they're very low between them. So the readings are actually pretty close to the other. We're talking about hundreds of kilo ohms, so 382 kilo ohms, that is. And that's what we're getting on the good one, okay? Now, when I measure on the bad one, watch this. $60 ohms. So our short is from there forward. When I say short, our leakage path to ground is from there forward. Now, to determine which of these is actually creating the short, if there is a particular one, I'm just going to measure the resistance on all of them. Remember, there's some resistance between these coils. That thing is 165 ohms. That one is 85 ohms. So the likelihood, this one is closer to our short than that one because it's lower resistance. That one is 60 ohms. It's closer yet to our short than the other two. That one, 36 ohms. That one, 47 ohms. So this guy has got a 36 ohm path to ground. And if we follow this guy all the way along here, I'll show you where it goes to. This thing comes to that pin over there. Okay, our 36 ohms. And we can check that. There's our 36 ohms, okay? There's no tube in, The only connection to this pin at the moment is this resistor, which if we put it across here gives us 1.06K to ground. So that short is definitely not there, it's there. If I look for a short anywhere down here, I can't find it. This is just a pin, which just happens to be pin 6 of that tube. And according to our tube diagram, or tube pinout, pin 6 over there is not connected. So what they've done is they've used, because they needed a resistor of 1K between the output of the transformer, the winding of the transformer, to that pin over there, they've used this as just a solder point. So our short, because this goes nowhere else, there's either going to be a short in the two pins over here, which I doubt very much. I hope that is the case. Or the short is actually back at the transformer. And the way the short could be at the transformer is that inside the transformer there's been some kind of spark, because it's not a dead short, it's 36 ohms and it's pretty steady. There's been a spark with the casing of the transformer, which of course is connected to ground. So there's some kind of leakage between this point, and my guess is it would be carbon residue from some kind of short explosion in there, or spark in there, that's creating a path to the chassis of this transformer on the other side, inside the transformer. So what I need to do now is I'm just going to disconnect this point from here and make sure that it's actually on the transformer and not on this path over here. That'll be the easiest thing to do. Now that that connection has been desoldered, we can measure it, and we find open circuit, so the short is not on that path. If we measure that point, there's our 36 ohms. So it does seem to confirm that there is that leakage inside the actual transformer. So the thing to do is to take the transformer out and see if it's not potted, first of all. If it's potted, there's nothing we can do, unfortunately. If it's not potted, then if it's something that's accessible and visible, we could actually clean it up and insulate it properly and remove that that path to ground. Because it not being 0 ohms, if you look at all the others, they're not shorted to ground at all. They're actually the exact resistance from this one to there. See, that is 36 ohms. That there is 160, call it 166, so 130 ohms. If I take this point and connect it to there, I get my 130 ohms. So in other words, this thing, these others, are at the normal winding resistance between them and that point inside the transformer. So I think we've found the source of the problem, and it's just a matter of taking this transformer out and seeing if we can see anything. And if it is potted, as I said, they sometimes just pump a whole lot of potting material in there, make it absolutely sealed, and you just can't get in there. That'll be impossible. But if it's not, we may well be able to fix it. Let me give it a shot. And here we have it. He's out of the housing. All it took was 4 screws at the bottom, after you take obviously the top cap off. And then you obviously have to desolder these. Now I'm going to open it up and see what we find inside. Hopefully not a potted transformer. And we have it. And we have, unfortunately, a potted transformer. Bloody hell. You see that mass in there completely seals it inside the unit, so you can't get to the windings. However, short could still be up here, so I'm going to open that up. I've got some good news and I've got some bad news. The bad news is I lost a bit of video. The power went dead and I thought I was recording and I wasn't. The good news is that it seems the fault is gone. Now I've got to explain to you what happened. First of all, let's test it. There's ground, just to make sure that's ground. Okay. Now watch this. Absolutely nothing to ground. Absolutely insulated from ground. These guys aren't soldered in yet. None of these are. Now I'll tell you what happened. When I took this top off, there was a bend in the wires at the top. And as I took the inside of this portion off, I didn't see it happen, but it looked like a little bit of sort of soot fell off. That's all I can describe it as. It's gone. It was literally like a, I don't know, a little grit of soot that fell off. And I thought, well, let me give it a shot. It's impossible that's all it was. But I went to test it. I tested this to the chassis, which is where the short would have been originally, and it wasn't there. It was gone. So am I convinced this thing is fixed? No, I'm not. I think it could well be that we had a little bit of carbon touching the chassis. However, this thing was actually blowing fuses. Now, that means that that carbon would have been passing quite a bit of current. So, quite honestly, I'm not sure that this is solved. However, it certainly looks like it. So the thing to do now is to solder these back together, do another test, and then actually power it up without the tubes in and see whether at high voltage we get a short. And perhaps take it from there. All right. I hate it when my pessimism proves well-founded. We've got the problem, and I've just realized what it is. The short is not to the case. It's between this winding and that one, or those there. Actually, that one or that one. So the short is actually not to the chassis or the leak. It's actually between this winding or this wire and one of the secondaries. So when you connect these two to ground, your short goes to ground. It's touching there now, see? So this transformer is really ill. The only thing I can say is we can't really open it up because it's potted. The leakage is between two windings, which is actually worse than if it were to the chassis. If it were to the chassis, you could somehow probably isolate it. You could probably make a plan. If it was shorting to the chassis, because it's actually shorting to one of the primary winding is shorting to the secondary winding, it's even worse, because you'll get leakage to ground because that wire there, that connector there of the secondary is shorted to ground. But worse than that, you could actually get leakage to further up the winding, which effectively means high voltage to the speakers, which is definitely not good. So the other thing is, because it's between two windings, it tells us that it could be right in the inside of the transformer and not just one of the connection points. So even if you could get it out of the potting, you probably still wouldn't be able to solve the problem. So yeah, unfortunately, it looks like that diagnosis was right. Not in the way that we expected, but certainly blown nonetheless. And that's not good news, because this thing is pretty expensive. But anyway, that was just a quick look, and I was hoping for a bit of a miracle, because these things don't happen that often. Power transformers blowing, output transformers blowing is not that common. Usually you'll get quite a few other things that'll go first, but in this case, unfortunately, that seems to be the diagnosis. All right. Hope that was in any way informative. See you again soon.